Okay.
All right, so we are solving question 2. And question 2 is about regression.
Mm.
Question 2 is what regression? Can you see the screen?
Yes.
All right. So whenever you are giving the question 2, whenever you are giving the question, what you first do is don't read all these parts. Don't read that part. Come and start reading from here and know what type of question it is. So you come and start reading from the A. So here it's called required. This side is called required. What you are asked to do, what the question wants you to do is called required or requirements. Required or requirements. Then you read down. So start reading for us.
Required. Interpret the intercepts and slope coefficients of the regression equation in the context of the hotel. Then B. Calculate the coefficients of dissemination and the percentage of variation in weekly bookings not explained by advertising expenditure. C. Copy and complete a table showing the predicted bookings and residual for each of the 4 weeks. Use residual is equal to actual bookings minus predicted bookings. D. Identify the week with the largest predictions error in absolute terms. State whether the regression model overpredicted or underpredicted bookings in that week. Use the regression equation for Use the regression equation to forecast weekly room bookings when advertising expenditure is one when adver when advertising expenditure is 1 800 Ghana cedis and II 1,200 Ghana cedis. F the observed the observed expe the sorry F the observed advertising expenditure in the table ranges from 200 Ghana cedis to 700 Ghana cedis. Explain why forecast for 1,200 Ghana cedis should be treated more cautiously than the forecast of 800 Ghana cedis. And then June, interprets the correlation coefficient. Regression is equal to 0.84. Sorry, 0.84 in the context of the hotel.
All right. So after you finish, so you could see it's on regression, right?
Yes.
Another thing else you could see that it's a regression question is you'd see X and Y here.
Mm.
X here. X here. Y there. You see it's some regression. Are you good?
Yes.
Okay, so now let's start reading. Let's read a question 2.
Should I read?
Yeah.
A hotel uses online advertising to generate weekly room bookings. The estimated regression equation is y is equal to 120 plus 18x, where y where y is the predicted number of weekly room bookings and x is online advertising expenditure measured in hundred of Ghana cedis. The correlation coefficients the correlation coefficients between advertising expenditure and room booking is regression is equal to 0.84. The following actual results were recorded during 4 weeks. So we
All right,
have
so that's fine. That's fine.
okay.
So that's it. We have the data sets, week X and Y. All right, so let's start. Interpret the intercept and slope coefficients of the regression equation in the context of the hotel. So we come here. It says the estimated equation. Have you seen it green?
Yeah.
There's this. So I'll record it here. Y estimates equals 120 plus 18x. The question says we should interpret the intercept and slope. So in this equation, the intercept is 120 and the slope is 18. Are you good?
How do you determine which is which?
The intercept is when you make x 0, y will be equal to what? So when I make this x, I change the x to 0, right?
Okay.
I'll be left with y hat equals 1, or y estimate equals 120 plus 18 into bracket 0, right?
Yes.
So I'll be left with this. That's when x equals 0. I'm going to have y hat equals what? 120. When I add everything here to give me 120. So the intercept is the point on the y-axis, right? So if I'm to draw a curve like this, let's say this is 50. This is 40, 80, 120, 140. So 140, 120, 100. Moment. So let's say 40, 80, 120, 160. So the intercept is the point on the y-axis. Which value on the y-axis will the curve about to be drawn touch on the y-axis? So this is the y-axis, this is the x-axis. Y-intercept says it is the point on the is the value on the y-axis which the curve you are going to draw here will touch the axis. Do you get it?
Yeah.
So at what value on the y-axis will the curve to be drawn touch the y-axis?
160.
What?
160.
Where is 160? 120 is here. Have you seen it?
Yeah.
So why were we saying 160?
Because that was the last figure.
That's what?
I thought that was the last figure.
No, no, no. It's this 120.
Okay.
It means that on the y-axis here,
Mm-hmm.
since y is 120, the curve you are going to draw will touch the 120 on the y-axis here.
Okay.
So when I draw the curve, it's going to be like this. This is how the curve will be. It will touch the y-axis.
Mm,
It is the value on the y-axis which the curve will intercept or will intersect. So when you say something is an intercept, someone is intercepting me. It means someone is like crossing your path.
yeah, interjection. Okay.
Yeah, yeah. The person is trying to cross your path. You are making a statement. The person will just cut in, right? The
Mm,
person try to block you. Like football. Messi has a ball, or Ronaldo has a ball. Neymar has a ball. He's dribbling, or he's advancing forth. Before he realize a defender will come and cross him. He has intercepted him. So
okay.
interception is just like crossing, right? But they said which value on the y-axis? On which value on the y-axis will the line cross or will the line touch the y-axis? The
Is
value is
what?
120. That's called the intercept. And this is called the gradient or the slope. It's like how the degree at which the curve will turn.
Okay.
Okay. How the curve is the steepness level, right? When you say
Mm,
something, it's like this thing is like a slope, all right? It's talking about how the curve will turn, how it will bend, the
yeah.
angle, the magnitude of the bending of the curve. Basically, that's what we will say the slope is like. Are you getting
Okay.
it? So the question
Yes.
is saying that we should interpret the intercept and slope coefficient of the regression equation in the context of the hotel. So you just write the equation back.
Mm-hmm.
You just write the equation we've seen there. You write the equation we've seen there. Then we start. We will say that the intercepts, mostly we say that 120 is like A. And because it's derived from the uh, linear equation standard y equals A plus B x.
Yeah.
Uh-huh. So the A is like the 120. So you can say A equals what? 120. Then you put a
Mm,
column. So that the A is also, so we can say Y is equal to alpha plus what?
Beta
Beta
X.
X. Yeah, that's it.
Okay.
You can write A equals, or you can write intercept equals this, 120. Then you say that, now what is it about? What is the whole model about? The hotel uses online advertising to generate weekly
Room
room
book.
bookings, where Y is the predicted number of weekly room bookings, and X is the online advertising expenditure measured in hundreds of Ghana cedis. Okay,
Like,
so let's go.
yeah.
So it means Y here stands for the weekly room bookings. X stands for the what? Advertising expenditure, right?
Yeah.
That's the year. So
Mm,
we'll say that, like I did before, when when advertising,
expenditure is 0.
good. When advertising expenditure is 0, you can write it this way, you can write in words, comma, weekly hotel bookings is what?
120.
Good. It's 120, 120. That's it. That's it. So that's the intercept. Then we go to the B. The B is the 18. I getting it. So we will just say that units increase in weekly hotel, no, a weekly increase in advertising expenditure, because that's the X, right?
Yeah.
In advertising expenditure will cause Y. The Y is the weekly hotel booking. Will cause weekly hotel bookings to increase by 18. mm, by
Mm,
18 units on average.
can I ask you a question?
Yes, I'm listening to the question.
Okay, so would there ever be a case where they will not give you the figures? They'll ask you to solve for like alpha and beta by yourself.
Yeah, it's
Okay.
possible. But this question, they'll repeat the same questions. Maybe they may change the figures. So
Okay.
if we find out that there are some other set of questions which require us solving for both, then we'll do that.
Okay.
But we are solving the trial question. The trial questions, this is a question they've set, so we are solving it as such.
Okay.
So when we are giving the interpretation, we say that the B, do you understand the A?
Yes, I understand the A.
Like when I solved it this way, Y hat green, I'm using green, equals 120 plus 18x.
Mm,
And I said when x equals 0. So
uh,
it should be Y hat equals 120 plus 18 times 0,
mhm.
right?
Yeah.
Which
So
gave
I
us Y hat equals 120. So we are just saying that since A is an intercept, how do we find intercept in the equation? When we make the other variable 0. So
yeah.
when advertising expenditure is 0, that's when X is 0. Y, which is the weekly hotel bookings, S means equals 120.
Mm,
Then the B equals 8. In the B, like I'm saying, I'm explaining over here, The B is like the 18, which is the scope. So a
Okay.
unit increase in advertising expenditure, that's that is the unit increase. That is when X increases by 1 unit. A unit increase in advertising expenditure, the advertising expenditure is X, will
Mm,
cause Y, which is the weekly hotel bookings, to also increase. Why? Because beside the 18 is a positive sign.
okay.
That's why it will also increase. If it were negative, it will decrease. So
So what
beside the 18 is positive.
okay. So what you're saying is that if it is y is equal to 120 plus 18, and then we decide to change the 0 to 1, if it increases here, it is going to increase another side because you are adding. So the more you add the figures in the bracket, the more it will be increasing.
I don't understand your question.
You understand? So let's assume y is equal to 120 plus 18x. Then you write y is equal to 120 plus 18 into bracket 1. So 18 times 1.
18 into bracket 1.
Yes.
No, 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 there's no need.
Okay. There's no need. Okay.
No.
Always be with 0.
If it is the intercepts, you just do it as I've done it.
Okay. That's fine.
Because you are finding the intercept. Intercept is at which point does the curve cross the y-axis. Meaning
Yeah.
you have to make 18, you have to make the x 0.
The,
On the left, why should we even make the x 0? Watch here. Because if you want to find the value which would touch when the curve touches the y-axis here, let's say it's 120 here.
mm,
If you want to, in other words, the curve will touch the y-axis, right? If this is the curve. This curve, which I've drawn, which is like the backward slash, it will touch the y-axis at 120. At that time, x is 0.
yeah.
This x-axis.
Okay.
So at that time, x is 0.
Uh,
So the curve will only be able to touch the y-axis when x is 0.
mm,
Also, the curve will be able to touch the x-axis at a given number when y is also 0.
okay.
Do you get it?
Yes.
That's how it is. So when you say intercept, it means that we want to find y-intercept. It means x must be 0, because when I'm plotting on the graph, I need two coordinates to plot the point, the 120 on the graph, which the x would touch or intersect or intercept. And the two coordinates, 120 is already on the y-axis, isn't it?
Mm,
We always need two coordinates to plot a graph. We need x and y. So if
mm,
the y is 120, what is the x? The x should be 0.
0.
So that the curve, when I draw it, will touch the y-axis.
Okay.
I hope you get it.
I understand.
So what if I'm to find x-intercept? What do I do?
If you have to find x intercept,
Mhm.
so x
No, no, don't solve it for me. If I want to find x-intercept, what do I do?
it's still 0. It's still the same thing.
No. If I want to find y-intercept, I'll make x 0 to find the y equals. It's just like y-intercept means find the value of y by making x 0. Or
Mm-hmm.
let y stand alone. Find the value of y by making, this equation has two variables, y and x, right?
Yeah. Yeah.
Y on the left-hand side, x on the right-hand side. So find y-intercept means make the other variable 0, which is the other variable is x, make it 0 so I can find y equals. So if I say find x-intercept, it simply means make y 0, then find the value of x. Do you get it?
Yeah.
Uh-huh. In this question, we have to find the intercept. The intercept is mainly for y, because
Mm,
y is deemed as a dependent variable. So how do we find the y-intercept, which is the a? It is when x is 0, then y will be equal to the a.
mm,
You get it?
yeah.
So when we make advertising expenditure 0, which is the x, we equate the x to 0 here. Look on the right, the green. When we make x is 0 is the theoretical part. The grammatical part is x equals 0. When we make it equal 0, as I've done the computation, y will be equal to y equals 20. So y here, which is called the weekly hotel bookings, S120. That's what I've written here.
Yeah.
So this is the mathematical expression. This is the theoretical or the English or the grammar here.
Okay.
Then the next one is B equals 18. X is the advertising expenditure. We're saying that when advertising expenditure increases by 1 unit, when advertising expenditure increases by what? 1 unit, the
The
weekly bookings, the weekly
is
hotel bookings will also increase by the B value. The B value is the 18 here on average. So a unit increase, we can say when, another way you can write this, when advertising expenditure increases by 1 unit, the weekly hotel bookings, which is the Y, will increase by 18 units on average.
okay.
Do you get it?
Yes.
Or a unit increase in advertising expenditure will cause weekly hotel bookings to increase by 18 units on average. That's interpretation. We are
Okay.
done.
Mm,
We are done with the A.
okay.
We are done with this. Let's go to B.
B.
Calculate the coefficient of determination and the percentage of variation in weekly bookings not explained by advertising expenditure. Okay, so let's go. We are at B, right?
Yes, B.
Do you understand it?
Yeah, I understand the A.
So the question says coefficients. I don't know if they'll give formula sheet. Coefficients of what?
So they'll give.
They'll give.
Yes.
Coefficient of determination. The formula is called R squared. And in the
Mm-hmm.
question, they give us the R. We're giving the R for the question, right? What we'll do here is we'll just square it.
At 0.84.
So the R will say where R is equal to what? 0.84. So R squared, which is the coefficient of determination, will be called what? 0.84 squared. What do we have?
The calculator. Okay, so 0.84 square. 0.7056.
4 decimal places.
I think they said we should keep it on 2 decimal or something.
Who said that?
They said that in class, but I don't know if it applies in the exams.
But start is 4 decimal places.
Okay.
If you want to keep it in 2 decimal places, first keep it in 4, then you change it to 2 subsequently.
Okay.
0 point what?
And 0 point. Please hold on. My calculator is 0.7056.
So you can keep it this way. Then you say equals, now I'll change it to 2 decimal places. 0.71. Then you say, you can write this APP, which means approximately.
APP. Okay.
You can write APP. Or you can say 0.0756. Then you bring this sign, 0.71. This sign represents the approximation sign.
Mm,
You don't want to write the APP at the end. You can just write it this way. The second one is correct.
okay.
Are you good?
Yes. I am.
Okay. So let's write the interpretation. Maybe it might not be necessary in the exam, but here let's write the interpretation. So if you want to write
Okay.
the interpretation, we'll say 0.056 times 100%, which will give us 70.56%. Are you getting it?
Mm-hmm.
So we'll say 70.56% of the variation in Y, which is the weekly hotel bookings, is explained by, right? It's explained by the advertising expenditure. Hey, they said online, oh, so you have to include the online. Explained by what? Online
Expenditure.
advertising expenditure. Are you good?
Yes.
So here, we will say when online, we will add it. Are you good?
Uh-huh.
A unit increase in online. They said it's online, so you have to include it. Are you good?
Yes.
So that is the coefficient of determination is 0.7056, approximately 0.71. Then if you want to write the interpretation, the question could say with and give the interpretation. This is the interpretation. We have just written it.
Okay.
Now, let's see. The question was in twofold. Calculate the coefficient of determination, which we have done. We are doing the interpretations. And the
Yes.
percentage of variation in weekly bookings not explained by the advertising expenditure. That is one is called the coefficient of non-determination. In other words, based on what you just see here, based on this equation, which explicit or which obvious independent variable affects weekly bookings? It is X,
X.
because you see
Yes.
it's written. That is
Mm,
called the coefficient of determination. That this X is causing a change in the Y by 70.56%. Are you getting it?
mm,
The coefficient of what they describe as percentage of variation in weekly bookings is called coefficient of non-determination. What other factors, right, causes changes in Y apart from X, which is the advertising expenditure? So we'll say percentage of variation, which is also known as the coefficient of non-determination. Percentage of variation. Because we can say that you could see here it is percentages, right? It's decimal fraction. Do you see it?
yes.
So we can say we can subtract from 1. 1 minus 0.7056. What would that give us?
0.7056. 0.2944.
0.294.
Oh,
Good. So this is the percent. This now they said percentage. You can multiply this by 100%.
very true.
You have 29.44%. I good.
Yeah.
Or another alternative is alternatively, you can say just pick the entire 100% and subtract this 70.56 from it. I getting it.
So
That will give
100,
you
70, 100 minus 70, 705, no, 70.56 is 29.44.
is this, have you seen it?
It's the same thing.
Yeah, I'm saying alternatively.
Oh, okay.
So if you don't want to use the first approach, you can use the second one, you get the same thing.
Yeah.
And that one, if you want to explain it, you say that 29.44%, 29.44% of the variation Now look at how the question places it. And the percentage of variation in weekly bookings not explained by advertising expenditure. So we'll say 29.44% of
Not
the
ex-
variation in weekly bookings, right, is
yeah,
not explained by advertising expenditure. Are you getting it?
yeah.
29% of the variation in
Mm-hmm.
weekly,
Bookings
yeah, hotel bookings is not explained
by
by
advertising.
online advertising expenditure. Are you getting it?
Yeah.
It means that the why, which is the weekly hotel bookings, other factors are affecting it, not only the X. That is what we've just done. Are you getting it?
Yeah.
And it's called coefficient of non-determination. Okay.
Mm,
Yeah, I think so. Yeah, let's proceed to the next question.
next
We are done with
question.
this.
Yeah. Copy and complete a table showing the predicted bookings and residual for each of the 4 weeks. Use residual actual booking minus predicted bookings.
Okay. So let's see. Copy and complete a table showing the predicted bookings and residue for each of the 4 weeks. Use residue equals actual bookings minus predicted bookings. Okay. So let's see what we can do. Let me check the question carefully. Okay, so watch here. This is what? Actual bookings.
Mm-hmm.
That is why,
Yeah.
right?
Yes.
And then they said it's advertising expenditure. So all these values are for X only.
Mm-hmm.
And yet they said these are actual bookings. Why? Now,
Um,
you've seen this Y has no hat on it.
mm,
There's nothing here on the Y.
yeah.
This Y hat, it is also called like this. Look at this one.
Mm-hmm.
Have you seen this one?
Yeah.
It's called Y estimate. The Y hat is the Y estimate. Meaning this value has been estimated, it has been predicted. It's not the actual. Are you good? But
Mm,
these bookings here, the values are actual. There is no hat on it. So what the question is saying is that we should go and compute the predicted one, this one. Then we'll
mm-hmm.
compare, we should go and compute the predicted Y weekly sales. Then we'll come and compare with the actual for each week.
Okay.
Then when we compare, the difference is called residue. Are you getting it?
Yeah.
So the actual bookings, which is the Y, they've already used a certain, already computed the Y value. So this is Y equals this. This one Y equals this. This one
Mm,
Y equals this. They've already done the Y. But this advertising expenditure for X will be used to compute the estimated Y. And I'm saying, how do you know this Y is estimated? You see the heart sign
what's on it?
or the caret on it, which is the heart sign. So this is estimated. So when this estimated is also known as predicted. Are you
Okay.
getting it? Or forecasted. So when we place in the X for week 1 into the Y hat, we will then get the estimated Y. Then we'll take out the estimated Y from the actual Y. That will give us the
Oh,
residual value.
okay. Okay. I
All right.
understand now.
Okay, so let's go. So we are on which question number? C.
Yeah, see.
We are on C.
So the
So
predicted
C, yeah, predicted equals what?
1 to
120 plus 18x. So week 1, where x is what? Week 1, what is x?
Let me 2.
2. So where x equals 2. So we'll say y hat or estimated y equals 120 plus 18 into bracket what? 2. Y hat altogether gives us how much?
I'm coming. So 18 times 2 is 36. Right?
So let's say
So
120 plus 36,
it's 156.
right? So this is estimated, but the actual y is what? For week 1.
It's 160. So we subtract it from
Good. 160. So we'll say residual equals y minus y hat. So 160 minus what? 156. How much will it give us? 4.
4.
Are you good?
Yes.
Let's do for week 2.
Okay.
Where x is what?
Where x is 4.
X is 4 for week 2. So we go here and say that y
Plus
hat equals 120
plus
plus
8.
18 into bracket 4. Y hat equals 120 plus 18. How much do you have here?
So 18 times 4. It's 72.
Plus 120. How much do you have?
192.
Okay, so we come to residual equals y minus y hat for week 2.
So
So week 2 was the actual.
So the actual is 188.
188. So 188. Hey. But y is equal to what? But the actual y is what?
Oh,
Eh, I'll head you.
1 8. Me, I must have you.
Because what? Y minus y hat.
Yeah. It's equal.
188 is not 4.
It's minus 4.
Good. Negative 4. Double underline. Week 3. Where x is what?
With the where x is 5.
Where x is 5. X equals 5. So y hat equals 120 plus 18 times 5. Y hat is what?
So 18 times 5. 90.
What do we have in all?
210.
But y equals, let's check week 3.
The actual
205.
205.
So we have
205 minus.
residual. Are you see the
It's,
way I'm solving it?
yes.
That's what I have to do it. So if you just go and add up anything, you don't write it for the
Write it
examiner to
down.
know what you are doing, he might mark you wrong.
Okay.
Y is 210. Y is 205 minus 210. What do you have? Negative 5.
5. 7.
4. X is what?
X
7.
is 7.
So where we have y hat equals 120 plus 18 times 7.
It's 126.
But I don't understand what you're saying.
18 times 7 is 126.
Mhm.
Yeah, so when you add it, you get 236.
Uh, It's not 46.
Yes.
But Y is what? Week 4.
200
Y is
and
238.
yes. Minus
So we come residual because what?
y minus y hat. Okay, it's the
So what do
247.
we have?
8 minus 8.
Okay, so we are done.
Yeah.
Let's move on to the next. We're done with this. D.
Identify.
Identify. Can you read?
No, you read. I should read.
Yeah.
Identify the weak and the largest predictions error in absolute terms. State whether the regression model overpredicted or underpredicted bookings in that week.
Mm. All right. So it says identify the week with the largest prediction error in absolute terms. Whenever you make a prediction and it's positive, it means it's let's say a likelihood of occurring. I getting it? Or you are having a right model. I getting
Mm,
it? So it simply is saying that which week gave us negative values. Those weeks are errors or are weeks with prediction errors. We didn't
mm,
predict it right.
yeah.
I getting it?
Okay.
So which weeks are they?
So the minus 4, which is
Now
week.
the weeks with the minus residual values.
Okay.
Mm-hmm.
So week 2
Hold on.
and week
So
3.
that's question number D.
Okay.
We have what's it saying?
So
Large week with largest prediction error in absolute terms. So week with largest prediction error in absolute terms. So we have week 1. Week 1, right? You said week 1?
no, week 2.
Let's check. So week 1, this is week 1.
Mm,
The value was 4.
that's fine.
So it's out. There's no error with this. Week
Mm,
2, the value is -4. So this one has an issue. So week 2
mm,
equals what?
minus
-4. Week 3, let's check.
minus 1.
Week 3 has -5. Week 4, -8. Are you getting it?
Yes.
But it says in absolute terms. Absolute terms means this -4 will become +4. Are you getting it? So week 2 equals -4, right? Will give us 4. Do you get it?
Yeah.
Absolute terms means that remove the negative sign, then make it positive. But you have to express it. I express the -4 in absolute terms by introducing the bars before and after the -4.
Okay.
That tells that it's an absolute, I'm dealing with absolute values. So week 2, so week 2, because when I introduce the absolute bias before and after 4, it means that I've converted a negative 4 into absolute terms, but I have to show it
Mm,
mathematically. So this I've shown it. Now I go to week 3. So how do I show week 3?
with absolute by -5.
Good. -5.
It equals to 5.
Week 4.
And then week 4 is -8, which is equal to 8.
So it says, which week has the largest prediction error in absolute
So,
terms? Which week?
so week 4 has the largest
Good.
projection.
Therefore, week 4 has the largest prediction error of 8 in absolute terms. Are you good?
Yes.
We are done. Okay, now it says state whether the prediction
Mm,
regression model over predicted or under predicted bookings in that week. That week 8.
week
Was
8.
there an over prediction or under prediction? So how do you determine that?
It goes
So
to the,
just come and check. Which week was it?
it was week 4.
So check the equation and tell me something. Did they over predicted or they under predicted?
They under predicted.
Yeah, they under predicted. Hey, check it well.
So the actual booking was 238, but then
Mm-hmm.
the hat booking,
They had what?
the predicted booking was 248, 246.
Mm-hmm. So was it an
So
over prediction or under prediction?
they over predicted it, but
Good.
the actual one was lesser.
Yeah. So the question says what? State whether the regression model over predicted or under predicted bookings in that week. So the regression model over predicted the hotel bookings, hotel bookings in that week, where the predicted bookings were or was 126. We can say was 126. Was one, is it 126?
So yeah,
246.
246.
Was 246. And the actual was, is it 238? I good.
Yes.
Okay, so that's it. That's it. Okay, so we are done with this. Use the regression equation to forecast weekly room bookings when advertising is 800 and when it is 200. So what do you think we can do?
So the regression equation.
Remember, weekly room bookings is represented by the alphabet Y, right? The estimated Y hat.
Yes, and the regression
The
is just
advertising is X. So what we began with, right? That's what they're asking us to do. So Forecasting weekly room bookings. So which number is this? E. So question E. Forecasting. A moment. Let me clean my screen. Okay, let's continue. E. E says, you're on E. E says using the regression equation. So it says use the regression equation. So you state the equation. What is the equation? Y hat equals what? 120 plus what? 89. This is the regression equation. So you should use this equation. For what purpose? To forecast weekly room bookings when advertising expenditure is I 800, I 1200. So you can just write this one, right? This for forecasting. Okay. So we go with this. It says when I is what? 800. When I, what is 800 cities?
Expected.
So when X equals what? 800 cities. So we should forecast. So we just bring the Y estimates. 120 plus 18, the bracket 800. What do we have? 120 equals what? Plus what?
We have 120. It's all 14,400.
14 what?
14,400.
Hold on for a moment. Okay, so 118 times 18, 800, what do we have?
14,400.
So we have 14,400. Okay, so what's the total?
14,520.
14,520. So that's the question says what? E says use a regression to forecast weekly room bookings. So when you finish, you can just write a short narration under it. I getting it.
Yeah.
You can just say, therefore, the weekly room bookings when advertising is 800 is 14,520. Hey, madam, 18 times 8, how much is it? Or what's the figure for 18 times 8?
It's 144.
It's 144. Okay,
Yeah.
but watch. Look at what the question says. It says that X is online advertising expenditure measured in what? Hundreds of Ghana cedis. I getting it? I getting it?
Yes.
It's measured in hundreds. So if they are saying 800, it is measured in hundreds. So if they are saying it's 800, we can say that it is 8 cedis if you want to do away with the zeros.
Okay.
Are you getting it? It says it's 800. It's measured in hundreds. X is measured in hundreds. So instead of saying 800, we can say it is what? 8
8.
cedis. Because the reason why I got prompted was because when you look at all the X values from the table, they are
Yeah,
all,
when
this is 200. This is 200. This is 400, but they use 2. This is 500, but they use 5. This is 700, but they use 7. Do you get it?
yes.
So yes, you have to use 8 instead of 800.
Thank you.
So this is 8. So this is what we have.
It's 144.
So when you add what we have,
So you get 264.
so you can use 264 what? Bookings. Do you get it? Do you get it?
Yes.
You can say 264
Booking.
estimated. What's the next one?
The next one is 1,212.
So it's 1,200 here.
Mm,
That's the E. So we go with 12. So X equals 1,200, which is equal to what? 12. So we say Y hat equals
120 plus 18 into bracket 2.
120 plus 18
Mm-hmm.
into brackets
So,
12. So how much is it?
so 216. 120.
Come
Y had
again?
120 plus 216, which is equal to 336.
So we can say 336 bookings.
Yes.
Or if we can just write 336, then you come below and write therefore the number of bookings is 336. I hope you get it.
Yeah.
That's it. It's not difficult. Let's go to F.
The observed advertising expenditure in the table reduced from 200 to 700. Explain why the forecast for 1,200 Ghana cedis should be treated more cautiously than the forecast of 800 Ghana
Mhm.
cedis.
So what can you say?
Well,
Mm-hmm.
I think the increase in the this one,
Mm-hmm. So tell me what you think.
the increase in it's different because the increase in the X would show the increase in the price. You get it?
Okay, so like you are collecting data, and
Mm-hmm.
the data, the observed advertising expenditure in the table, this table,
Uh-huh.
ranges
Ranges
from
from
2 to
uh-huh.
7. So it is based on this, they were able to come out with this predicted value. This.
Okay.
But this time around, they are giving us values, they ask us to find values which are outside the range. You see here is 800. How you seeing here is 800.
800 year.
Here is 1,200. So 800 is the same as what?
8.
8. 1,200 is the same as what?
Mm,
12, right?
uh-huh.
That 8 and 12, are they in the range?
No, it's up to 7.
Uh-huh. Meanwhile, the question got its model by using this range 2 to 7, 200 to 700. It says
Mm-hmm.
explain why the forecast of 1,200 should be treated more cautiously than the forecast of 800. So we've been asked to predict 812, which are all outside the range. But why is that we should be careful with the 1,200 compared to the 800? Uh-huh.
Hmm. So then I'll go back to explaining um the I'll go back to explain that when we use 200 and when we use 700, when we use 800, which is full, we got 365 degrees. And but when we use 1,200, which was 12, we also got 336 bookings.
Okay, or we can also say that the range is 200 to 700.
Uh-huh.
If it is 200 to 700, after 700, which figure is next? Which round figure is next?
800.
So that one, it is closer. Are you getting it?
Mm.
Uh-huh. But look at 1,200. It's far from 700.
Yeah.
In other words, 1,200 is wider or farther from the data set range. So here, there are probabilities that, okay, the figure of 336 will
Mm-hmm.
not be real. Or there are probabilities that the figure of 336 or the 1,200 for the forecasting will not give a proper picture for decision making. Are you getting it?
Yeah.
Because we got this model, which this y hat equals 120 plus 18x, right?
Mm-hmm.
Technically, before we can derive a model, it is based on the data set. And the data set is that the x values which was used to get this was between 200 to 700. So if we use it, if you want to use it to predict any value, to predict any weekly bookings, the figure should also fall between 200 to 700. So we have 2, 5, 2, 3, 4, 5. Let's look at the table. We have 2, 4, 5, 6, 2, 5, 4, 5, 7. Do you have 3 in the table?
No.
Does it fall within the range?
Yes.
Do you have 6 in the table?
No.
Does it fall within the range?
Yes.
Do we have 5.5 in the table?
No.
But does it fall within the range?
Yeah.
So mostly when we have the model, we should use it to compute values within. Are you getting it? Values
Okay.
within the range that is from the 2 to 7. Even if it would
Uh,
extend, it should just go a little above the last one.
it's not 120. Okay.
Good.
And
So if you get 1,200, which is far above the range, it means that it might give us an unrealistic value.
yeah.
It might also give us a proper picture to make decision on the why.
Mm,
So that would be the answer for the F.
okay. So
That would be the answer for the F.
so
So that one you
where
write. Have you understood it?
I understood it.
So you write it in your own words.
Okay. So
I
in
don't want
my
to write. This one is grammar. I don't want to
yeah,
write my grammar for you.
yes. Can you
So
go back? So
again,
mm-hmm.
again, explain why the forecast of 1,200 should be treated more cautiously than the forecast for 800. This is because
Mm-hmm.
the online advertising expenditure ranges or the data set ranges between or ranges from 200 towards 700, right? Based on
Yeah.
which the regression model was estimated. Based on this, the regression model was estimated. Therefore, um, values between 200 and 700 will give a proper picture of the weekly hotel bookings, right?
Yeah.
However, or values from the 200 to the 700, right, can give a proper picture of the hotel bookings, weekly hotel bookings to make a decision. A little bit about the 700, which is the last range, the upper limit. A little bit about the 700 is the 800, which can also be determined or which can also be predicted by the model. Are you getting it?
Yeah.
However, 1,200 is on the higher side, which is far above the range for the advertising expenditure data set. Do you get it?
Yeah.
Uh-huh. As a result, this will not give us a proper picture of the weekly hotel bookings for decision making by management. Are you getting
Mm,
it?
Yeah.
So that's how it should be. But if you use your range, your limit, your lower limit is 200, your upper limit is 700. It's reasonable. You can use both to make decisions. But then when you go and pick 800, 800 is quite okay. Even 900 is quite okay. But 1,200 is very far. Meanwhile, it is based on this range you made this prediction. Are you getting
Mm.
it?
Yeah.
It's based on this you are trying to make this prediction. And then you are using 1,200. It will cause the data set to be, it is called, mostly it is called extrapolation. You are going out of your boundaries. Are you
Mm.
good?
Yeah.
So that's it. So that one, since you've understood it, use your grammar to write it. Are you good?
Yes, I am good.
Okay. So G says, explain the correlation coefficient in the context of the hotel. So G, the, so let's say R, the, so when you say the correlation coefficient, 0.84.
It's
Mostly, we use a diagram to illustrate it like this. By then, I don't use diagram, just you write the interpretation. This is 0, this is -1, this is 1. So the correlation coefficient, it should be between -1 and 1, and with the middle is 0. Then we have here to be 0.5, here to be -0.5. Are you getting it? Then
mm-hmm.
here, from the 0 to the right, we say it is positive. Then 0 to the left, we say it is negative, right?
Mm-hmm.
Then from 0.5, we say it is strong. Is it strong positive and weak positive? Is it strong positive and weak positive? There is a strong positive. I think it's strong and weak positive. Let's keep it that way. So this one is, I think, and this is strong or very strong and strong. I've forgotten. Here too, on the other side, let's see it. We have weak here. Then between this and this is strong. Are you getting it?
Okay.
So between 0.5 and 1, it is strong. Between 0.5 and 0, it is weak. But sometimes there's another dimension, but because it's a lower level, let me put it this way. So he said we should give the interpretation. Interpret the coefficient correlation in the context of the hotel. Interpret the correlation coefficient R equals this in the context of the hotel. So we say that now we have the correlation coefficient to be 0.84. So
It's
0.84, where will it fall? Which of the quadrant will it fall? Based on what you have indicated.
it will fall strong positive.
Yeah. So you see that there is a strong positive relationship. Or the correlation coefficient of 0.84 shows a strong positive, you write positive in full, relationship. Are you getting it?
Mm-hmm.
Between X and Y, between the online advertising. Are you good?
Mm-hmm.
Between the online advertising and what? Weekly hotel bookings. Do you get it?
Yeah.
Uh-huh. So there's a strong positive relationship or correlation between online advertising and online. What is it? Is it online? What is that? Online advertising expenditure. Add it. Online advertising expenditure, XP, right? And weekly hotel bookings. That's all.
Okay.
So we have done this on the type of regression. But let me see if there's another type of regression here. Okay. Okay.
There's another one.
Should we solve it?
Yes.
Okay, go go. My style, okay. I think I'll use different one to write. Where is that? Which question number is it?
Is the C?
Okay, copy and complete. I didn't even see it. Copy and complete a table showing the predicted bookings and residual for each of the 4 weeks. Oh, okay. So it means that at the C here, we should have constructed another table where we
Yeah.
just repeat the same thing
The, yes.
and complete a table showing the predicted bookings and residual for each 4 weeks. So we'll just write, that was the first one, week, right?
Yes.
So after this, after the week 4, where is it? After the week 4, over
Mm-hmm.
here. Oh, I'm using green over here.
Yeah.
I could have drawn a table and made it week
Required
uh, advertising expenditure, advertising expenditure.
actual booking and predicted booking.
Is that I should copy the table. So advertising expenditure,
Mm-hmm.
right?
Mm.
Actual bookings,
Yes.
predicted bookings. Then I'll show residue. I getting it.
Mm-hmm.
So week 1, week 2, week 3, week 4. Then I'll put in the values. What just so this side, I'll copy them from the table.
Yeah. So to
Uh-huh. Then the week 4, the actuals, I'll copy all, then the predicted. I got here to be week 1 was what was the predicted for week 1?
the required was 160.
156. So I'll put 156 here. Week 2 was this 156.
It's
The
156.
predicted was 156. This is it.
Yes. Yes.
Week 2, predicted is 192.
So this one is there.
Week 3, predicted is 210.
Mm,
Week 4, predicted is 246. Right?
mm-hmm.
Then the advertising expenditure is two, I think it's 2, 4,
Two,
5, and
four,
7.
five, seven. Yeah. And then the actual one is 160,
Mhm.
188, 205.
188.
Yes.
Mhm.
205 and 238.
205 and what?
238.
238.
Mm-hmm.
Then the residue, the difference, I'll record them here. So that one would have come below the workings.
Yeah.
So I've come here. Uh-huh.
Mm.
So from there, I didn't read that. Okay. Let's see what we have for the next one. We are
Okay.
taking question 8.
Okay.
This is question 8. Hey, my stylus pen is not writing on the screen.
Mm-hmm.
Are you okay?
Yes, I'm okay.
Let me open a new sheet and check. Okay, so hold on.
Okay.
Otherwise, using the mouse to write will be difficult for me. Okay, let's start. So question 8.
Is the pen working now?
Yeah, it is. Question 8 is also regression. I went through a question. It's just like the previous one, but some slight changes. The one we first did, we used correlation coefficients. And this one, so, okay, before you start, what is the first thing to do? Let me see whether you remember.
The first thing is to go and read the question about this.
Okay, so let's read through it. So the first thing, come and read this portion. These are requirements, right?
Hmm.
So read.
So calculated D is equal to X minus Y and D squared for each outlet A minus J. B. Calculate Spearman's rank correlation coefficients. C. Interpret the direction and strength of the relationship of the relation of the relationship. Yes. D. Interpret the intercept and slope of the regression equation. And E. Calculate the predicted repeat customers and residual for outlets H and I. And F. Identify the outlets with the larger outlet prediction error and state whether the model overpredicted or underpredicted. Okay.
So it's similar to the first one.
Yeah.
Okay. So after that, what do you do next?
So after that, you write this one down. So you come and reach the top.
Mhm.
A,
So
re-
what the question is saying is that this is okay, you finish reading. Finish reading.
a restaurant group runs 7 outlets according to food quality and repeat customer rates. Rank 1 represents the highest position. So,
So we
so
have
this
the outlets, food
mhm.
quality rank, repeat customer rank. Let's continue. And it's A to G. Continue.
Okay, for a separate group of outlets, the estimated question is the estimated equation is sorry, y hat is equal to y estimated is equal to 30 plus 4.5x, where x is the number of customer service training section and y is the predicted monthly number of repeated customers. Outlet H conducted 5 seasons and recorded 50 repeated customers. Outlet 1 conducted 8 seasons and recorded 63 repeated customers.
Okay. So this regression is called the Spearman's, yeah, that's the name. Spearman's rank correlation coefficients. So
Mm,
let's come here. The name is called the Spearman's rank correlation coefficients. And the other one is called regression. This one is called regression. Is here. Or this is regression actually. Okay.
okay.
This is Spearman's rank correlation coefficient, similar to regression. So let me clear
Okay.
this. It's similar to regression. So this is what we are solving today. All right. So the first question says, let's check. Calculate dx minus y and d squared for each outlet. So each outlet means that I have to bring my d here. I'm using blue. I have to bring my d here for each outlet, A to G, right?
Mm,
Then what's the next one? I have to find, so I'm finding D and what?
I
D squared. So after
yeah.
finding my D, then how do I find next? D squared.
D square.
Very good. So I'm going to
Mm,
repeat the same table here. So how many columns? 1, 2, 3, 4, and
5.
5, right?
Mm,
So I'm going to have A. So what's the first one? Outlet
yes.
XY. I'm just using outlet XY. So outlet here, X here, Y there. Then D. And it
Mm,
says, the question says D is equals what? D equals what? X
X
minus Y.
Y.
So dx minus Y. Then I'll find my what? D squared. Very good.
Yeah.
The outlet is A to G. So A, B, C, D, E, F, G. Then my X's are 1 to what? 7, right?
Mm-hmm.
Here, 1 to 7.
Mm.
So 1, 2, 3, 4, 5, 6, 7. Then my Y's, I have 2, 1, 4, 3. 2, 1,
4, 3, 7, 5,
2,
6,
1, 4, 3,
7, 5, and 6. Hey,
7,
no.
5, 6,
2, 1, 4, 3, 7, 5, 7,
6.
5, 6. Yes.
Yeah, so 2, 1, 4, 3, 7, 5, 6.
So X minus Y is equal to minus 1.
Yeah, so this is minus 1. This is 1. This is minus 1. This is 1. This is minus what? 2. This is 1. This is 1.
No, this one is just 2, 5. Okay, yeah, sorry, minus 2. Hey, you ready? 1. 1.
Are you
Okay.
good?
Yes.
Then the last one, what do we do?
So,
Negative 1. You put it in a square. What do we have?
minus 1 squared. Hey, I'm coming. Please, I'm coming.
If you make it, listen, if you make it this way, you get negative 1. But we put it in a bracket, you get 1. So this is the appropriate method.
Okay.
Do you
That's
get it?
1. Yes. But you keep wrong value.
This is also 1. There's 1. There's 1. This is 4. There's 1. There's 1. Are you okay?
Yes, I'm okay.
Mm. Okay. So I'm not going to do anything here. Let's wait and see something. Let's go to the next one. This is done. We are done with this. B says what? Calculate the Spearman's rank correlation coefficient. So let's check whether the formula is in the formula sheet. You see the regression? Regression, we have a formula where we can find the A and the B, right?
Yeah.
And the B to have a formula. So here, let's check whether the Spearman's rank correlation coefficient is in the formula sheet here. Oh, sorry.
You have the formula sheet.
It's not here, it's here. It's in the question itself.
Uh-huh.
So here. This regression. This one is for regression. This one is for regression. This correlation coefficient.
Mm.
So we are looking for the Spearman's rank correlation. It's not here. This is for sample standard deviation and variances and co. That's it here. The variances. sample and the population variance. So it's not here. So let me ask online for the formula for the
Okay.
Spearman's rank correlation coefficient. So Google, let me ask Google, give me the formula
I think the
for
formula is
Spearman's.
N. Can I try? N sigma XY minus.
Let me get it. I don't have it here.
Okay.
Okay, this is the formula. Have you
Hey,
seen it?
yeah. Regression square.
It's not in the formula sheet. But in
Mm,
the exams, if they will bring this question, they will introduce the formula. Or you have to keep the formula in mind. Just in the event it's not displayed or shown or included in the list of formulas. Are you good?
yeah.
So the question 2 says, the B says, question 8, calculate the Spearman's rank correlation coefficient. It's also R. But you say RS, like the formula is given, RS. So we
RS.
say the B. So B, RS equals 1 minus 6. The I is not relevant. So 6 sigma D squared. So 6 sigma D squared over N into bracket N squared minus 1. I good.
Yes.
N into bracket N squared minus 1. So we can put all these guys in the brackets.
Mm,
All right, RS equals 1 minus. So if they said sigma D squared, right?
yeah.
If they said it's sigma D squared, it means
Mm,
that this D squared we see here, I'm using red.
mm-hmm.
This D squared we are looking at here, we must add the total to it. So let's bring sigma here. Then we'll add all the D squared values. We'll add all the D squared and write the total so that when we are solving it, we can replace sigma D squared, this thing,
With the
with the
figure.
value here.
Okay.
So let's add them. 1 plus 1 plus 1 plus 1, that is 4.
Oh,
8 plus 2, 10.
yeah.
So it's 10 here. Are you good?
Yes.
Okay, so let's go. So R squared here is 1 minus 6. Sigma D squared is what? 10.
And
All over. N is the number of observations. How many alphabets? A to G, how many? 1, 2, 3, 4, 5, 6, 7. Do you get it? So we can say that where N equals 7. So 7 into bracket 7 squared minus 1. Do you get it?
uh,
So RS will be equal to 1 minus 6 times 10 is what? 60, right? Over the bottom. What will the bottom give us?
uh, the bottom will give us 7 squared minus 1. So 48 times 7. 7 times 48.
So yeah, so do it together. What does it give us?
336.
Mhm. So RS equals, now do all this on the calculator. 1 minus into brackets 60 over 336.
So 1 minus into bracket 60 over 36. I got minus 0.66666. Is it correct?
1 minus into brackets. Okay, don't worry. 60 over 336, what do we get?
60 over 336.
Mhm.
You get 0.16.
I've told you, you have to leave it in 4 decimal places.
Okay, so 0.1639.
So you first write 1 minus, what's the figure? 0 point what?
0.1639.
Now you can subtract it. What is our RS?
So 0. Our R is 0.8361.
That's our RS. Are you getting it?
Yes.
That's the Spearman's rank correlation coefficient. This is the value. So we are done. We double underline this. Let's go to C. Interpret the direction and strength of the relationship. The direction is, so C. The direction is just like this one. It's just like this one. This is like this one. You see, here is only R because that's the regression correlation. We have the
Mm.
regression correlation, then we have the Spearman's correlation. Regression is R, Spearman is RS. So is it positive direction or negative direction?
A strong positive.
Good, that's it. So that's what you write here. I good. But here
Yeah.
it says, watch, interpret the direction and strength of the relationship. So first, let's say, as the RS is positive, okay,
Mm.
we will say there is a positive relationship. That's the direction. I getting it?
Yes.
Or let me put it this way. It says direction, 1, and then what? Strength, right?
Mm.
So we can write it this way. What is it? The direction. As the RS is positive, there is a what? Positive relationship. Between what? Between what? Between the X and Y. I good.
Yeah.
So you can say there's a positive relation between X. You write the full name of the X. The X stands for what?
The X stands
Food
for
quality
quality rank.
and repeat customer rank. So food quality. So there's a positive relation between food quality and what? Repeat customers. That's the direction. And the strength. And what is about the strength? So also as the RS approaches 1 or is closer to 1, or the RS of 0.8361 is nearer to 1, what would you say? Look at this and tell me.
It's a strong positive. It
Yeah,
has a
there's a
strong
strong. Yeah. Even in
relation.
some books, some books could say there's a very strong positive.
Mm-hmm.
I getting it.
Yes.
So there is a strong relationship. I getting it. So
Mm-hmm.
putting both together, we can say that as the RS is positive and is approaching 1, that's if you are putting them together, as the RS of 0.8361 is positive, please write it in full, and approaching 1, there is
Strong relationship.
a strong positive, or you can say there is a positively strong, whichever way. Are you getting it?
Mm.
Relationship between the food rank, between the food quality rank or food quality and what? Repeat customers. Are you getting it?
Yes.
So you can choose to write this and it's come and write the last one, or you can choose to write the last one. It's also correct. Are you good?
Yes, please.
We are done with this. The D. The D, you should be able to do the D. So the D, the E, the F, we are going to do it together
Okay.
because we've done it earlier, the first question. So the D, interpret the intercept and slope of the regression equation. This is a regression. I've seen the same thing.
Yeah.
It means this question, one will go to regular, one will go to weekend and evening. Because there are
Mm.
two different sets. So one will go here, one will go, the other will go the other way. So this equation, which is the question D, Y estimates or estimated Y equals 30 plus 4.5x. 30 plus 4.5x. Says interpret the intercept and slope of the regression equation. Okay. So what is the interpretation?
So let's first solve it.
It's just like this. It's just like this one.
So 30.
Watch, watch, watch. It's just like what we did here. Yeah, yeah.
Mm. Use black.
Very good.
Yes.
It's just like what we just did here. Yeah, yeah. So what's the interpretation?
So the interpretation is that when
Uh,
x is equal to 0,
this follows the regression equation y equals alpha plus beta x. Have you forgotten?
no,
Yeah, yeah. Where is it? Yeah.
yeah, let's go.
Isn't it?
Yes.
So if they say should interpret the intercept, this equation, which one is the intercept?
The intercept is
Look here. Which one is the intercept?
120.
So here, which one is the intercept?
It's 30.
So this is the intercept. This is the slope. So
It's
you can
true.
say that. let me use a different variation. Here, I wrote the A here, the A here, black. I wrote it
Mm,
here.
yeah.
And the B here, black, below the 18. That's it here.
Yes,
So
yes,
here, let me change it. So I can say here, intercepts
is one
equals
thing.
what? 30.
Sorry,
Then
30.
you write the interpretation. Or you can say A equals 30, like the first one.
Yeah.
So what should we write?
So we'll write that
Quick.
when we'll write that. Can we go back to the question?
No, you said we should interpret the intercept and slope. So what do you write?
So write that the intercept is equal to 30. When um when 30 is when 30 plus 4.5.
No, no. Look, watch here, watch here. When advertising expenditure, which is the X, is 0,
Okay.
Y is 120. So what does the Y stand for? What does the X stand for? Y stands for
The
repeat
food
customer.
repeat customer, yeah.
X
And
stands for food quality. So when what? We are find the intercept is for Y. We have this is that you find the intercept, it means make Y equal something. So for you to
so
make
when
Y equal something, which one do we make 0? Between Y and X, which one becomes 0?
0 x 0.
X. So what does X stand for?
So the X stands for repeat customer rank.
Are you sure? Look on the
Food
screen.
quality, sorry, food
Rank.
quality rank.
So when what?
So when repeat customer rank,
I'll head your lips.
when X is
Between
0,
the
when
Y
food
and the
quality,
X, which one should be 0?
the X, when food quality rank is 0,
So when food quality rank is 0,
when food quality rank is 0, X is equal to, Y is equal to, sorry, Y is equal to
we
30.
are we are we are giving interpretation. We are still repeating Y.
Repeat customer rank is equal to 0.
Yeah.
30, sorry.
If
Jesus.
I would have taken your head off your neck.
What have the question? That is why.
It's 30, that's correct. On average.
On
Or you can
average.
choose not to bring the on average. Okay.
Yeah.
Let me just clear the on average. It's not compulsory. You can rather say all things being equal, but it's not relevant. Are you good? So that's the
Yes.
intercept. What's the next one?
It's a slope.
So you can write slope here equals what? 4.5. Bring a column. Or you can just write B, just as we did the first one.
Mm-hmm.
Yet you can write A equals 1 to 0. You can write intercepts. You can write B equals 8. You can say slope. How do you explain it?
So we explain that and an increase in repeat customer rank, which is a 0.
I'll head your lips. Always an increase in X first. Do you understand me?
Yes. Increase in X would cause an increase in the
Don't write X. You are giving interpretation. I'm
so
asking you what does AMA means? Then you're also telling me AMA is AMA. So, interpret what AMA means, the full meaning of AMA. And you're telling me AMA is AMA. I
so
get it.
increase in the food quality rank
An
will also increase by 4.5.
increase in the food quality rank by 1 unit.
Repeat, yes, by 1 unit.
Will also
Increase in
Will also
in
increase
increase repeat customer rank
mhm, by what?
by
4.5 units.
4.5 units.
Yeah, that's it. So always the X will increase by 1 unit. Then the Y will increase by the coefficient of the X. Here, the X increased by 1 unit and the Y increased by 18 units. Are you getting it?
Mm-hmm.
That's it. So we are done with this side. Send your thing. We
Mm-hmm.
are done with this side. E. Calculate the predicted repeat customers and residual for outlets H and I. Calculate the predicted repeat customers and residual. Okay. It's just like the first one we did. Yeah, we are using the regression. Okay. They said for H and I are not in the table because it's only A to G.
Yeah.
But they gave it here. H and I are here. H is conducted 5 sessions and recorded 50 repeat customers. So this 5 sessions is the X.
Mm.
50 repeated customers is the Y for H. For I, 8 conducted sessions is the X. 63 repeat customers is the Y. Are you getting it?
Mm-hmm.
But the issue is this we're seeing here, right? It's just like the
Mm-hmm.
first one. The
Mm-hmm.
Y here is an estimate.
Okay.
And the 50 repeat customers you are seeing here are the actuals.
Okay.
So here, this Y we are looking at here,
Mm-hmm.
okay?
Yeah,
Repeat
that.
customer rank. These
Mm-hmm.
are the actuals, just like the first one.
Mm.
So the difference between this capital Y without a caret or hat and the one with the hat is that this one is estimated. This is
Okay.
estimate, and this one is actual. So for each of the values we have here, right? If we insert 1 into this formula,
Mm-hmm.
the estimated value will be more than the actual.
Mm.
The same applies to the Y. The same applies to the H here and the I there. Are you getting it?
Yes.
For the H, there's the X 5 sessions, and there's the actual 50. So you want to find the estimated H, we'll plug in the 5 to replace the equation, to replace the X, then we get the estimated. Then we'll compare the
Mm-hmm.
estimated Y with the actual 50. Then we know the residue. Are you getting it?
Yes.
So just like saying H is here, I is here. Then the H, X is 5. Then the Y is what? 50.
Mm.
I is 8 here.
8 and 63.
And the Y is what?
60.
63. And it says you find the residue. So the residue is that these values are actual because they are capital Y's without hat. But these 5
Mm.
and 8, come and plug them into the estimates to get the estimated values. Then you compare to get the residue. Are you getting it? To
Yeah.
get the residual values. Are you getting it?
Yes.
So that calculate the predicted repeat customers and residual for outlets H and I.
HMI.
So let's go. So we go to E.
Mm-hmm.
So we have H, outlet H, 5 sessions and 60 watts recorded customers. Are you getting it?
Yeah.
Outlet H, black.
Yeah.
Let me use red. Red, outlet H, 5
Mm.
sessions, 50 repeat customers. So it's not 60, it's 50.
It's 50.
Yeah. So 50 repeats, not recorded.
Yeah, I've believed it. Okay.
Mhm.
Mm.
Okay, so we write a regression equation. Y equals what? Y hat or Y estimates equals what? 30 plus 4.5x. I get.
Yes,
So for each, where x is equal to what? For each, where
5.
x equal to what? 5. So Y hat equals 30 plus 4.5 into bracket 5. Y hat equals 30 plus what?
It's 22.5.
All equals what?
52.5.
But the actual Y equals what? 50. Yeah, I
50.
believe what you are doing is correct.
Yes, it's correct.
You let me, I don't trust you.
Oh, it is correct.
Okay. Then we have residue or residual. Residual equals what? The actual minus the estimates. What is the actual?
The actual is 50.
Residual is what? 52.5.
52.5.
So what do we have?
2.5.
Wrong. Negative 2.5.
Hey.
Then we go to outlet I. Do you understand it's negative 2.5?
Yes, I understand.
Outlet 5, we have one, we have 8 sessions, 63 repeat customers. 8 sessions.
It's outlets June.
I'll head
And
you.
answer is I.
We are looking for I. That
Okay.
G, we are not dealing with them. I. Outlet I. Red, this. Red arrow.
Yeah, absolutely.
8 sessions and 63 repeat customers.
Mm.
68 sessions, 63 repeats customers. So the regression equation is, what is it?
Y hat
Yeah.
Y minus,
Y hat equals 30 plus.
yes, it's for 30 plus 4.5x.
So where x, what's the value of x?
8.
8. Y hat equals 30 plus 4.5. What is x? 8. Y hat equals 30 plus, and what do we have?
So this was 4.5 times 8 is 36.
So total, what do we have?
66.
But the actual is what?
So the actual is
63.
53.
Yeah, it's 63. So
Yeah.
residual will be equal to the actual minus the estimates. So what is the residual?
So the residual is 3.
So 63 minus what? 66. Have you forgotten your calculations?
No.
Minus
Minus,
3.
sorry.
So it says calculate the predicted repeat customers and residuals for outlets H and I. We are done. Are you getting it?
Yes.
You double underline this. You double underline this. Let's go to F. Read it.
Identify the outlet with the larger absolute prediction error and state whether the model overpredicted or underpredicted.
It's just like the first one. So what do we do?
So we go to the brackets, which one is the biggest and the smallest, and we'll find out if they underpredicted or overpredicted.
It says identify the outlet with a large absolute prediction error. The prediction errors are those with the negative values.
Minus, yeah,
So you go to the two we worked on. Which
yeah.
one of them have the negative values?
So A had negative.
Hey, those are
No, no,
not
no,
part.
no. Okay, so the two we work both though, they are all minus.
So identify the outlet with the larger. Okay, then you have to do for all of them.
All of it. I was about to say it. But there's
You
only
have to do for A to from A to I.
should I do them?
Let's do it. Let's do it here.
Okay.
Okay. So it says, let me watch. Let me read the question carefully. Yeah. So what we'll do is simple. It's very simple. We'll draw the table again.
Mm.
So we have outlets
A.
A, B, C, D, E, F, G, H, I. Hey, wait, oh, wait. If you do it that way, it will be a long process.
So let's just solve it since we
So
know.
we will take, no, hold on. Hold on. Let me test something. Have you seen A to G is 1 to 7, right?
Mm-hmm.
Hold on.
Yeah.
Okay, hold on. Let's use only H and I to test it.
Okay.
Let's use only H and I to test it. So it says, because if 5 is giving us negative, 7 may, but look at the value here. This is 6. I get
Mm-hmm.
it. So let's only use H and I. Are we good?
Yes, I know why you want to use H and I.
Why?
Because H and I is really far from this one that they gave us.
Yeah, it's outside the range.
Yes.
Yeah, that's correct. Let's say, no, let's say H and I they are not actually outside. 5, you see, 5 is not outside the range. I see 5 is in,
Yes, it's in.
but 8 is not.
Mm-hmm.
Are you getting it? But we
Mm-hmm.
are using both because look at the values of the Y. This is 2, this is 1. Are you getting it? Uh-huh. And in fact, even if we are to insert the X values into the equation, they will still give us negatives.
Mm,
Are you good?
yeah.
They will still give us negatives. They will still give us negatives. Let me watch something carefully. They will still give us negatives. Hold on. Rank 1. They will still give us negatives. But let's
Yeah,
use
no,
H and
that's
I. Yeah, let's use H and I and see. We are using H and I because it was based on the H and I. We calculated a predicted, I getting it,
mm,
residual. Because that's what the question asked us to calculate. The previous one, the question asked us to calculate the predicted on the weeks, all the weeks. But here, we calculated the predicted on the outlet of H and I. Are you good?
yes.
Uh-huh. If we go and choose from A to G in addition, it will give us higher values of negative values. Or it will give us higher negative values. For example, if you choose X as 1, right? And you plug the 1 into this equation, right? It's going to give us 34.5, which is the estimated. You get it?
Uh-huh.
Minus this 2. Now
Two
remember,
is
these two here
32.
are ranks. They are not values.
Mm,
These are what? Ranks. They are not values. But this 50 repeat customers is turn out the total customers who came back. I don't know if I'm making sense.
Yes, you are.
The Spearman's rank correlation coefficient is talking about ranking, how we rank them. This is the first, this is the second, this is the third, this is the fourth, this is the fifth, this is the sixth, this is the seventh. Are you getting it?
Yeah.
So that if you go and choose the A to G, we are not going to get very good values because these 2, 1, 4, 3, 7, 5, 6, they are rankings. This is the second position. This is the first, this is the fourth, this is the third, this is the seventh, this is the fifth, this is the sixth.
Mm-hmm.
But the 50 and 63 here are the total number recorded, not ranking.
Okay.
I hope I'm making sense.
Yes, you are.
That's it. So we choose the H and I. We find a prediction. We choose the H and I on which we found the word predicted customer values. Okay. So those two, we had negatives for them, right?
Yeah.
On H, this is H. We had
Minus
negative 2.5.
5.
On I, we
Minus
had
3.
negative 6.3. So outlet H
Okay.
equals what? Negative 3. Absolute value is what? A.
This,
Negative 2.5, right? Is that
wait.
correct?
No, please. Yes, yes, yes,
Outlet
yes.
H is negative 2.5.
Yes,
Then outlet I is negative 3, right?
yes.
We are finding the absolute value. So these two, which one had the higher? It says identify the outlet with the larger absolute prediction error. So these two, this outlet, which one had a higher absolute prediction error? Quick.
So 2.5 and 3. Um,
Which one is greater?
mm.
Which one is
So
greater?
the one that is greater is the one is 15,
One
63.
is 2.5, one is 3. Which one is greater than the other?
3.
So that's it. The question says, identify the outlet with the larger absolute prediction error. Absolute, change all the negatives to positive. Which one is the larger, the bigger one, the greater one?
3.
So the outlet is I. So we say outlet I has the larger, not largest, larger because there are only two items, larger prediction error. Are you good?
Yes, I am.
Yeah. And state whether the model over predicted or under predicted. So the model.
So with that one, the
So look at the models. The model for the one with the larger prediction error, was it over predicted or under predicted?
it was over predicted
How do you say that? Why do you say that?
because 66, the actual one was 63, but the predicted one was 66. So it means
Okay.
that yes, yes, that predicted.
So let's look at the question again. And say whether the model predicted or over predicted or under predicted. So the model was over predicted because the estimated what
Very
the estimated Y. What does the Y stand for?
the actual
No, repeat customer. Here, don't
repeat.
use rank. If you use rank, the estimated, the Y hat,
Mm,
the Y hat here is estimated and it's 66, right? So the
Oui.
estimated repeat customers was 66, more than the what actual repeat customers of what?
63.
Of what?
63.
63. Of 63. That's it. That's it. So outlet high between the two, outlet I has the larger prediction error. The model was overpredicted because the estimated repeat customers was 66, greater than or more than or above the actual repeat customers of what? 63.
Yeah.
We are done. We are done.
Can we check if there's more question on it inside the trial question?
No, that's all. The others are mean frequency distribution. That one is for another time. So we've solved 2 out of 10. We are left with 8. The
Okay.
next time we'll see what to do.
All right.
So
So,
practice them.
okay.